I'm Rachel Meliotis, a senior editor at O'Reilly Media at Velocity, New York, 2013, and I am here with Jake Archibald, web platforms engineer at Google.
Yes.
Thank you for joining me. So you're giving two sessions here. Let me get the titles. What your browser does when you aren't looking, and rendering without lumpy bits, which I love. Tell me a little bit about what they are and how they're set apart from the other stuff that we're offering.
Well, so the first one, which is what's the browser doing behind your back? It's built around this idea of a quiz. So people were there with their phones. I would present a question, which would just be a small amount of markup. It was just asking which browsers, if any, are going to cause an HTTP request to happen at this point. And people were able to play along live, answer with their phone, and it would show on the screen what the mood of the room was for each browser. So you can kind of see if they didn't trust one browser in that situation, the needle would swing the other way.
Cool.
It was kind of pitched as something that was kind of concentrating on HTTP requests, but it was really just an excuse to sort of get into the browser internals and sort of say, you could say just because this is requesting an image can often be a restriction on the rendering layer. So it's a good excuse to stop and say, oh, this is how the browser actually does its rendering, and this is why in this particular situation, one browser and maybe not another one are actually going to trigger that request. Rendering without lumpy bits. This is, I think it's one of the, it's something people aren't caring enough about at the moment. Is that even at Velocity, there are a lot of talks on the network performance, and that's hugely important because the user's seeing nothing until that stuff has arrived. But once you're there, once the app is fully loaded, if the user's scrolling and it's all over the place and it's really slow, people, even on a psychological level, that's got a huge impact. I mean, so Facebook did this study where they artificially reduced the frame rate of their mobile app. And when they did that, they saw a drop in engagement when they were doing that. So it's trying to get that point across that people really need to care about having a smooth user experience, how you can use the GPU, and how you can get 60 frames per second.
Interesting. Very good. So there's many challenges in web optimization, and they often revolve around the browser. Do you think that developers will ever be free of sort of the browser's demands?
Well, what the standards have to do when they define a web standard, it needs to be there to last. Like we still want the first ever web page to work in a browser today. So we don't want to add an API that is tied to a particular architecture that's not going to be here tomorrow. And that's one of the problems we have. And we see this with the web, websites a little bit older that weren't made when mobile phones were around. And there's a lot of particular APIs that were made at the time that were not really thought through, and they're not working today. One of them is in CSS, where you could say, this is intended for handheld devices. But people were intending it for the handheld devices of the time. So then we got like a modern batch of smartphones that would not declare themselves as a handheld device because they didn't want to be given that lower standard.
Right.
So we need to sort of avoid creating standards like that. But I think very much that developers are able to sort of drive through what they want in the browser, and we see that with JavaScript libraries. Like we see what people are doing with JavaScript, and then it's a job of the people who are making the browsers, the people who are making the standards, to see that and go, we need to make that faster. We need to be able to do that without JavaScript, and we can do it faster, and we can decide whether how we're going to do that based on what the device is, what its connectivity is. We saw that recently on the resource priority spec, where you could put postpone on an image, and it would decide, it could defer that download if it's hidden, and it could defer that download whether it's like just further down the page out of scroll view. And on a mobile device, if it's got a cellular connection, it could just download it even if it's out of view, because it's more optimal to do that, to use the radio while it's awake. Whereas on a desktop machine with a good Wi-Fi connection or an Ethernet connection, it can defer starting that download of the image and get a better response time by deferring it. So we've seen lots of JavaScript libraries and things like query selector all. This has all come from things like jQuery. So I think developers are sort of affecting the standards and what the browser does maybe more than they think.
Yeah, I was going to say, it sounds like maybe the standards and browsers are getting a little bit more flexible because of devices probably, and maybe developer, I don't know if I want to say requests, but usage.
Well, definitely, and I think the major bit of stagnation we saw in terms of specifications was because of stagnation in the browser world, and we saw that with Internet Explorer 6 sitting there. Things would try and be added speculatively to a spec, but it would never be implemented, so just things didn't move. It's not like that anymore. Chrome is getting a new version out there every 6 weeks, so things are getting from the spec into developers' hands so quickly now.
Interesting. So another topic that you have, I believe, been writing about is progressive enhancement, and that's sort of an evolution from graceful degradation. sort of goes along with everything you've been talking about so far. Can you talk a little bit about why you're a fan and how it's evolved from graceful degradation?
Yeah, I come at progressive enhancement from entirely a performance perspective, because there's a lot of people saying that the important thing about progressive enhancement is things should work without JavaScript. But there aren't many people with JavaScript turned off anymore. I mean, and I don't think that's someone we should be catering for, unless you've built a site where you have a particular security concern. You've got a lot of users that are likely to run no script for that reason. But
Sure.
most people don't have that. From a performance perspective, with progressive enhancement, you can just deliver HTML, CSS, and you can get to that first render. And then your JavaScript comes in and does stuff. I try and frame it as if you were going to build like Photoshop in the browser, we wouldn't want to do that thing that the main application does and have that splash screen where you stare at everyone's names who are responsible for this long wait, and then the interface opens up. Because what's
Right.
on the interface is just a few buttons and a menu. That doesn't need that long wait. Why am I waiting for the lens flare to load while that's happening? So if you're to build it on the web, deliver just HTML, CSS for that interface, and then in the background sneakily start downloading the first thing the users like to use, which would be, the only thing they have to do is open an image at that point, load that behavior in, load the decoders, and then at some point later you can start thinking about the filters. And that's how I see progressive enhancement. The opposite, the old way, graceful degradation, it doesn't have that speed instance. The next point of where progressive enhancement is going to become important is dealing with offline. So we're working on the service worker at the moment, so it's just going to be this new standard to deal with making offline work in the browser. We've seen that the application cache didn't work, we're going to do something better. But the best way to make something work offline is to treat the network connection as a piece of progressive enhancement, or a potential enhancement, because it might not be there. And if you do graceful degradation with the connectivity, like you make a network request, and if the user's offline, you give them the offline experience. If the user has 1 bar of mobile reception, that is, I don't know, I've spoken before, like it's like your phone becomes like a one-legged dog trying to play fetch. It's just sort of scraping itself along the ground, and it's depressing watching it going, please, the information's on the phone already, give me the offline experience, but no, it's going to try and make that connection. So that's where you would do progressive enhancement. Load the data that's already there, display that, and then attempt a network connection. And if you get it, great, update the data. If you don't, that's offline. It's great.
I think it makes a lot of sense. Where do you see web performance moving in the next 5 to 10 years?
We're going to see loads more on the GPU. I mean, that was the surge forward we saw a few years ago, moving a lot of stuff to GPU layers. We're going to see more and more GPU rendering. I mean, a lot of the drawing in some browsers today is still software-based. We're going to see that move on to because there's a card sitting there in the machine that's dedicated to this stuff, and it's only recently that we've been making some kind of use of it. So that will happen more. The browsers every version they're getting better and better at that. But I think the next leap forward is going to be this service worker. So websites that have an offering or can make an offering offline will start to do that. And that will make their just general performance so much faster, because you open the app and you will get you'll get the last thing you saw. And this is what people are expecting from native apps. And so we'll get that as well. So if you loaded Twitter, you would get the thing you saw last on Facebook, and then there'll be a spinner to show the data come through.
Sure.
And that will just feel so much faster to the user.
Sounds all great to me. Thank you for joining me.
Thank you very much.